Okay, so in this video I'm going to go through section 11.5, proportions with area. So what we're going to do is a little investigation to determine a formula. So if we find the area of both of these triangles, let's do the small one first. We just do base times height divided by 2, so that's 12. Okay, and then this one would be base times height divided by 2. Just to make this a little easier, I'm going to cross cancel or divide. 12 times 9 is 90 plus 18, so 108. Okay, so now write the ratio of the smaller area to the larger and reduce. So 12 goes into 108 9 times. We get exactly 1/9. Now do the same with the side lengths and compare these ratios. So this is the ratio of areas. And the ratio of the side lengths, so 3 to 9 and 8 to 24, those are both equal to 1/3. So now what happens when we compare these? What we have to notice is that if we square this one, we get the ratio of the areas. So if you take either one of the ratios of the corresponding sides and square it, you should get the ratio of the areas. So we'll do it again in case you, just with a different example. So with circles in terms of pi, so the area of this circle would be 9 pi because 3 squared, and this one would be 4 pi. Write the ratio of the smaller one to the larger one and reduce, we just get 4 over 9. So that's the areas again. Now if we do that with the radii, we get 2/3. And notice when we compare, again, if you square this, it will be equal. So then we come up with this formula like this. This is the one that we want. If we take the m and the n represent corresponding sides or corresponding radii or corresponding heights, anything, if we square that, it will be equal to the ratio of the areas. Okay, so we'll do some problems where some things will be missing and we'll have just enough information to solve them if we use this formula. So trapezoids are similar. We know the area of the large trapezoid is 1155, so that's going to go here. And then the area of the small trapezoid is what we want, so we could call that x or a or whatever you want. And then these are the corresponding sides that were given. Those go into this formula here and here. And so I always do small over large when in reality it doesn't matter. You can flip both proportions, but just to be on the same page. So the small side divided by the big side, and we square that. That will equal the area of the small divided by the area of the large, which is 1155. Now we have a proportion that we can solve. The first thing I usually do is try to simplify the left side. So you could do 10 squared is 100, 30 squared is 900. So just square each one of these individually. It's like distributing sort of. So that's equal to, we cross out the zeros, that's equal to exactly 1/9. Now if you did this on a calculator, you might get some weird decimals, like this would be 0.11111. And then this would be equal to, let's just say a over 1155. So now if I have this fraction, I can cross multiply 1155 times 1 equals a times 9, and then I just divide by 9. So 1155 divided by 9 is 128 and 1/3, so 0.333. Okay, if you had the decimal at that point, 0.1 repeating equals a over 1155, then you'd have to do 1155 times 0.1, and you have to type in a bunch of ones, or type in 1/9. You get the same thing. Okay, example 2. Let me just go through that. So example 2, we've got similar triangles. This time we're told the ratio of the areas is 4/9. So the 4/9 is actually this part. And then we're missing the altitude of the smaller one, so that goes in here, and the altitude of the bigger one goes here. So a over 12 squared equals 4/9. So there's a couple ways to solve this. You could do it the same way I did before and square both of these, a squared and then 12 squared, and then cross multiply. Or you can take the square root of both sides and do it like this, the square root of both sides, and just do these individually. Square root of 4 is 2, square root of 9 is 3. So this equation is a little bit easier to solve because now we just have 3a equals 12 times 2, and we can see a is 8. This one, when we multiply, we get 9a squared, and then 144 times 4, kind of a larger, we get 576, and then we would have to divide by 9. So a little bit more work here. That's going to be equal to 64, and then we take the square root at the end, and we get the same thing. I prefer actually the second way, where you just, if you're told the ratio of the areas, all you really have to do is take the square root of them and then set that equal to the ratio of the altitudes. So that's it for this section. Again, this formula, I will give this to you in a little formula sheet. So you just have to know that M and N can stand for any corresponding sides, altitudes, radii, heights, anything. So I'm not going to tell you what M and N stand for. You'll have to know that part and how to use this. Thanks for watching. Goodbye.